Welcome to the lecture on Evaluation Part 2. Part of the material presented in this lecture is taken from the following book. Transcription and interpretation errors are responsibility of the lecturer. In this lecture, the following concepts will be introduced: symmetric and asymmetric objective measures and selection of objective measures. Besides the measures we have described so far, there are other alternative measures proposed for analyzing relationships between pairs of binary variables. These measures can be divided into two categories: the category of symmetric measures and the category of asymmetric measures. Concerning symmetric measures, we have the following. A measure M is defined to be a symmetric measure if the following condition is satisfied. M, the value of the considered measure for the association rule A implies B, is equal to the value of the measure M for the rule B implies A. In particular, we have that the interest factor is a symmetric measure. Indeed, we have the following chain of equalities. The interest factor for the pair of items A and B is defined to be the ratio of the support of the pair of items A and B to the ratio of the product of the support for the item A times the support for the item B. This is also equal to the support of the pair of items B and A, where we simply exchange A for B and B for A, and we know that the support of BA is by definition equal to the support of AB. Then we obtain the equality to the right, E of BA. This shows then that the interest factor for the pair of items A and B is equal to the interest factor for the pair of items B and A. Therefore, we can conclude that the interest factor satisfies this condition and thus it is a symmetric measure. We now shift the attention to asymmetric evaluation measures. In particular, we have that an evaluation measure M is defined to be asymmetric if the following inequality holds. M, so the evaluation measure of the association rule A implies B, is different from M, so the evaluation measure of the association rule B implies A. A typical example of an asymmetric evaluation measure is offered by confidence. Indeed, confidence is an asymmetric evaluation measure, because by definition we have that the confidence of the association rule A implies B is defined to be equal to the ratio of the support count of A joined B divided by the support count of A, which in general is different from the support count of B joined A, which is equal to the support count of A joined B, divided by the support count of B, which in general is different from the support count of A. And we know that by definition the support count of B joined A divided by the support count of B is equal to the confidence of the association rule B implies A. Therefore, we conclude that in general the confidence of the association rule A implies B is different from the confidence of the association rule B implies A. To add something more, we have that symmetric measures are generally used for evaluating item sets, while asymmetric measures are more suitable for analyzing association rules. We have that the symmetric measures include correlation, odds ratio, kappa, interest, cosine, Jacquard, and collective strength, while asymmetric measures include the Gini index, mutual information, certainty factor, added value, J-measure, and Goodman-Kruskal index. A wide variety of objective measures is available. It is reasonable to question whether the measures can produce similar ordering results when applied to a set of association patterns. In particular, it is important to understand what their differences are in order to determine which measures is more suitable for analyzing certain types of patterns. Accordingly to what presented in the specialized literature, we have that the following symmetric measures, correlation, odds ratio, kappa, and collective strengths, may not be suitable for analyzing asymmetric binary attributes. While in the specialized literature we have that the following symmetric measures, interest, cosine, and Jacquard, are preferred for asymmetric binary attributes. It is worthwhile to mention that cosine is equivalent to the IS measure in the case of binary attributes. Furthermore, the specialized literature shows that symmetric measures as cosine and IS measure and Jacquard are particularly used for document analysis and market basket analysis. By contrast, the following symmetric measures, correlation, odds ratio, and interest, must not be used for document analysis and market basket analysis. All the measures presented so far are defined for pairs of binary attributes. However, many of such measures, such as support, are also applicable to larger sized item sets. Furthermore, interest factor, IS measure, and the Jacquard coefficient can be extended to more than two attributes using the frequency tables tabulated in a multidimensional contingency table, as those reported hereafter. Here we have a contingency table for the pair of items A and B in the case where there is the presence of the item C, while to the right we have a contingency table for the pair of items A and B in the case where the item C is not present. The meaning of the elements of these two contingency tables can be described briefly as follows. Here we have F111, which stands for the number of counts of elements in the transaction database, where we have that the item A is present with item B and also with item C. The same meaning can be associated to all other elements of the two contingency tables. So in this case, putting together these two-dimensional contingency table and this two-dimensional contingency table, we obtain a three-dimensional contingency table, which allows to define the interest factor I of the three items A, B, and C, which is equal to n, the number of transactions, powered to 3 minus 1, times F111 divided by F1 plus plus times F plus 1 plus times F plus plus 1, all the elements that can be read from these two different contingency tables.